Kia katahi, kia kaha, kia pikari. Tihe Māori ora. Nau mai, haere mai, ina hou e wha whanui. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Hello and welcome to today's Spotlight webinar, coming to you from our respective bubbles at this time instead of the Spark Innovation Studio. Thank you for joining us today. My name is Shyam Nathu. I am a Business Development Manager for IoT here at Spark, and I'll be the host for today's session. Before our speakers get into their presentations, I'll just go through a bit of webinar housekeeping. You are welcome to send in your questions to Gavin and the team during the webinar. Simply type in your questions in the questions area on the right-hand side of your screen. We'll be answering those at the end of today's presentation. During the session, we'll also be running a poll, which we'll put up partway through, so be sure to jump in and have your say. We will share the results of that poll during the webinar. Also to note, this webinar is being recorded and you will have an access to that recording after this webinar has concluded. I'd now like to welcome today's speakers, Gavin Williamson, Guy McPherson and Maria McIntyre. First off, Gavin will be kicking things off for us. Gavin Williamson is a science graduate and began his professional career working for environmental organisations including Fish and Game and DOC. He then moved into industry in various environmental management roles. He has been with Mercury and its predecessor, Mighty River Power, for a number of years. Much of this time, the power stations on the Waikato River. Gavin is passionate about water management and over the past 18 months has been coordinating Mercury's aspirational vision to collaborate with willing organisations and make the Waikato the world's best catchment. Gavin, over to you.
Thanks, Shyam. Tēnā koutou katoa. I guess I just wanted to kick off by talking about why Mercury is interested in real-time monitoring. So our core business, of course, is generating and selling electricity, which means that we actually have, it gives us a privileged position as an operator of the Waikato hydro system, which also puts us in the middle of water management issues and challenges in the catchment. So our 9 hydro stations, long-standing assets, the oldest date back almost a century, which gives us a long-term view across a large part of the catchment. Now, the Waikato is New Zealand's longest river. It's a complex interconnected catchment. We also consider the catchment from not just the source of the Waikato, but also including the Tongariro diversions, which supply about 20% of the inflows into Taupo, and right through to Auckland's drinking water. Now, I don't have to tell anyone on the call that there's significant demands on water generally, but also in particular on the Waikato River, challenges around water quality and quantity. And the river supports multiple communities as well as being hugely significant for its own identity as a taonga and tupunaawa. So now also after many years of participating in RMA processes, we have realised that collaboration and working together is actually the best way to protect the river and the complex environment. And that's why, for Mercury anyway, our why is an aspirational vision for the Waikato to become the world's best catchment. And to us, this means the values of the river are protected in the first instance and its communities are also successful. So the why for others may be slightly different. This why is pretty consistent with Te Turu Whaimana, which is a vision strategy for the Waikato River also. Now, to make good management decisions, we all need access to the best information. And at the moment, water quality information comes from monthly sampling of around 70 plus sites across the catchment, which is great for long-term trends. It's also great for large, stable water bodies where change happens slowly. But real-time data is what will help us understand those short-term changes. And we all know that water quality can change weekly or even daily. We have surges following rainfall. Even in the summer when the flows are low, you can get daily fluctuations in dissolved oxygen as plants are respiring and photosynthesizing. So real-time monitoring gives you that real richness of data, and that's what continuous monitoring is about for us in terms of, as I say, opposed to monthly data. So what's the journey so far for us? We started in 2017 after being, I guess, inspired by the work from Te Ara River Iwi Trust, or TARIT, who with support from Waikato River Authority started reporting water quality in their rohe in the upper Waikato River. This was on their website via a dashboard provided by Takiwa. Now, the river water quality data was provided at that time by EcoDetect using capillary zone electrophoresis technology. So after seeing the potential for real-time monitoring and how it aligned with our long-term vision for the catchment, we supported some early trials and eventually settled on our partnership with Adroit and UV spectrometry sensor tech. So what have we done so far? We've set up the Whirinaki stream site in collaboration with the local catchment group, Whirinaki Catchment Group. Now, these are largely, it's a farming community. The catchment group are a group of really enthusiastic landowners supported by the regional council who've been doing some fantastic work around restoration in the catchment. And they were already starting to wonder about the science and whether or not their restoration was actually working. So they were already starting to think and were doing some turbidity monitoring already. But it gave us an opportunity to partner with them and set up the Whirinaki site. So how's it gone? I mean, the technology has been everything we hoped it would be so far. The sensors have performed faultlessly, and the Adroit platform is super easy to use, and especially the smartphone app. And I actually find the smartphone app pretty addictive when you can sit there and watch changes in water quality on your phone. So we're now preparing to install our next site in partnership with Ngāti Tahu Ngāti Whāua, also in the upper catchment. And this time we're going to locate adjacent to flow gauging station so that we can combine the chemistry and flow to report mass flow data. So being able to quantify the volume of nutrients and sediment will obviously provide us all with much more useful and quantitative data. And we have 3 more sites in progress and growing. So we're pretty excited about where we're going. So what have we learned so far? I guess we've learned certainly to go with proven technology. It's important that funders have confidence in the equipment, and it's challenging enough to get large organisations to invest in something that is not a legal or a consent requirement, without it also on top of that being an R&D project. So what else have we learned? Partner with a good provider, and Adroit certainly have been easy to work with. They know their equipment and they deliver. I guess most of us, and certainly I'm not, are not a tech expert. So our lesson has been find someone who lives and breathes this stuff. And these guys think they must dream in IoT. So it's been really important to get your tech provider right. Now, if you can, and this is really our experience, work with landowners, with farmers, catchment groups. They're super passionate about land management, and we've found they are really hungry for the data. But I guess this is, again, everybody's different and the why is different. But for us, this has been all about community involvement, and you may have a different why. Partnering with iwi has been super positive for us as well. Our iwi partners in the Waikato have been awesome, and they absolutely get real-time monitoring. And it's a great fit with Mataranga Māori thinking, the world of Te Aora Māori, and fits really well with real-time monitoring in the now. What's happening in the water now. I guess probably one of the best, or one of the learnings, I mean, we knew it was going to be the case, but real-time monitoring's a great educational tool. If you choose a good dashboard, then being able to watch the data live is infectious, and it's got huge potential right from schools through to boardrooms. I guess the other point I would make is make sure that the data you're collecting is relevant to the science and regulatory community. And I guess we're still working on this one. To be fair, we've jumped in and started collecting a whole bunch of data that we thought was relevant and was certainly relevant to us. But our next step is to make sure we've got great quality assurance processes around the data we're collecting, and that we're collecting data that starts to answer questions for the community. So what does the future look like in our view? So for the Waikato, we're targeting large-scale real-time monitoring across the catchment. And I would note though that it's obviously not our core business. So we're looking to encourage corporates, councils, iwi, community groups, etc., to also come on board and think about the benefits. And a bit of a shout out to Fonterra team, who I know are on this call. We have some conversations underway around collaborating around sites, and I know they're looking to stand up at least 2 sites in the Waikato catchment now. So that's great to see. And I guess looking future, we see real-time data, as I've said, as being able to help us all make good management decisions, better targeting of our restoration activities in particular, and actually knowing whether we're making a difference. I guess another given for us looking forward is open and free access to real-time water quality in a way that supports communities and educates. And I guess just a quick challenge out to industry and municipals that are already collecting real-time data, and there's a lot of it being collected across the country. And I would just hope that that we can start getting some of it out on websites and visible for people to see. Anybody should be able to freely jump onto a site and see real-time data. And imagine a world where you've got something like the Lawa site, where you can jump on there, you can look at real-time sites right across the country, and you can see data as it is now. So yeah, just to wrap it up, future for us looks like corporates, councils, landowners, central government, all collaborating to support real-time monitoring and ultimately working towards what's best for the catchment. So looking forward to your questions and comments, and I'll wrap it up there. So kanui ki te honere, kanui te honere ki te mihi ki a koutou. Over to you, Cheyenne.
Thanks, Gavin. It's awesome to hear about all the work and progress you guys have done over the last 4 years coming through there. Before we head over and pass you through to the Adroit team, it's now time to pop up our poll question. So audience, if you head over to the poll tab on the right-hand side of your screen, you'll be able to participate. We'll leave that up for the next 10 minutes, and then we'll look at the results at the end of the presentation. Our poll question for today is, what is your main barrier to implementing real-time catchment monitoring? The options are 1, I need a better understanding of real-time monitoring benefits. 2, I need more information on how the technology works. 3, I will have difficulty securing the funding for that project. Or 4, I have other barriers not listed above. Now we're going to hear from the Adroit team. So I'd like to introduce you to Guy and Maria. Guy McPherson, General Manager, Adroit. Adroit General Manager Guy McPherson is a tertiary trained business executive with broad expertise across multiple industries with 20 years experience in complex, high-value customer acquisitions and a flair for operations and business growth. Experienced in technology, distribution, and business systems development, he heads up the Adroit sales team and has been working with catchment groups, farmers, and our primary industry clients since joining Adroit 4 years ago. Guy has been instrumental within the Waikato catchment project rollout and is extremely passionate about how real-time solutions are aiding farmers and catchment groups across New Zealand. Maria McIntyre is a business development manager for the South Island for Adroit. Maria is an Irish environmental scientist with extensive experience in business and development manager and customer-facing roles. She has a passion for achieving sustainability through technology. She has a strong determination to help improve our relationship with our lands, our rivers, our resources through working with real-time IoT environmental monitoring technologies. Guy and Maria, over to you.
Awesome. Thank you, Cheyenne. First off, thank you, Gavin, for obviously bringing Adroit into this. It's been a pleasure to work with you so far. In terms of who is Adroit, what do we do? So Adroit is a New Zealand-based company that utilizes real-time environmental monitoring to monitor utilizing IoT technology. So we monitor water, air, weather, soil, and a range of others. But first, what is IoT? So the Internet of Things allows you to collect real-time data from wirelessly connected devices. A common example would be utilizing smart power meters. So this is where the power companies are monitoring data and sending that up and utilizing that for reporting and billing purposes. So what about a droid? What do we do? So we globally source best of breed environmental sensors. Then we bring them in-house where we integrate them as an IoT solution for a particular use case. We use a nationwide service team to install and maintain that solution. And that solution is monitoring particular parameters, and we're then sending that up via the Spark network to our cloud IoT platform. As part of the service, Adroit designs, installs, maintains, and supports each of these IoT solutions. So, what are some of the industries and clients we're currently working with? We work in aquaculture, so we work with king salmon, monitoring their fish farms. We work within the mussel industry, so there we've got data buoys out in the ocean monitoring salinity. They're closing and opening their harvesting times based on this information. We're working with worksite monitoring, so that's where we work with civil construction, working with customers such as Fletcher's and As-Built, looking at noise, vibration, dust, and this is all about compliance and all about mitigating complaints. And obviously we're working with catchments. So this is where we're working with Mercury, the community, and looking to work with Fonterra. And this is all about understanding water quality. So what Maria and I are going to go through is some of the commonly asked questions. So over to you, Maria.
Awesome. Thank you so much, Guy. Good morning, everybody. So I'm going to give us a rundown of the equipment we use, how it all works and fits together. So one of the main benefits of using a droid, as Guy has already touched on, is we source best-in-class sensors from well-established brands. We then use our in-house development team to integrate this equipment into complete solutions. So what does a typical catchment monitoring setup look like? On your left, you will see the setup that we have used for the Whirinaki stream that Gavin spoke about. It's also what we're going to be installing for Fonterra and Department of Conservation. It's made up of 4 main components. So in the middle, you have a IoT controller. So this is a data controller. It's the heart of all of our droid solutions. So it's made by a brand called Libelium. Libelium are from Spain. They've been in the market for 15 years. There's 6 ports in the bottom of this. We're just using 2 of them for this solution. So on the left, we have our S-Scan nitrate UV sensor. So S-Scan is a brand that come from Austria. They've been in the market for 21 years. There's around 10,000 of these installed globally. So we have quite a few of their sensors on our suite. This particular S-Scan sensor is called the Nitrolyzer. So it is monitoring your nitrates, your turbidity, and your total suspended solids. It's self-cleaning with a wiper on the inside that cleanses the lens once an hour. So the reason that we have chosen the S-Scan brand is its 5-year back to base calibration and low power usage. So it comes calibrated and it's a 5-year lifespan. So on the right-hand side, we have our multi-parameter sonde. This is by a brand called In Situ. In Situ have been in the market for 40 years. They're from the US. They have massive amounts of experience in the water quality industry, and many of you have probably heard of In Situ. So at the bottom of the sonde, this section will twist off, and it will allow you to plug in 4 sensors. For this setup at the Whirinaki stream, we're using dissolved oxygen, temperature, pH, oxygen reduction potential, and salinity. It also is self-cleaning with a wiper that cleans the lens once an hour. So this whole setup is powered by solar. It will go 5 to 7 days on power on solar if there's no sun. It can also be powered by mains. It just depends on your site requirements. So in the center of the slide, you have an in situ sonde and a Libelium data logger. So what we just wanted to point out, while the S-Scan monitors nitrates and turbidity, if you didn't want to monitor nitrates, you would just use the in situ and the Libelium data logger, as it can monitor turbidity. And then on the very right-hand side, we have our big, beautiful aquaculture monitoring data buoy, which is an MPI-approved solution. So we have these monitoring mussel and oyster farms around the country. We have one off the Firth of Thames. Recently, during a storm, it went 7 meters underwater. And half the mussel farm washed away, but the data logger inside was still pinging off data at the end of it. So it's super robust. So now you've got your setup installed. How do you get the data to the platform? So our solutions are connected via the Spark Cat M1 network. So the Cat M1 network is a network that is specifically designed for IoT devices. So it sends small packets of data and it sends them further. It's secure, it's reliable, and quite often where you don't have cell coverage, you're going to have Cat M1 network coverage. So this means that we're installing these in the most rural of places. If something does happen to your connectivity, there's a data bucket. It's going to store your data for 1.5 days, so you're not going to lose it. Back to Guy.
Thanks, Maria. Okay, so what does a catchment installation look like? So here's 2 examples of installations we have done. And the first thing you can see is they're obviously different. So depending on the flow of water, the stream, the actual bank, all of these things that come into how we're actually going to design the solution. So what we do is we have a nationwide service team that can come and organize this installation for you. And part of the main components of these, I'll just go to the next slide, is based around first the deployment pipe. So this is where we take the sensor or the sonde and we slide it down the deployment pipe into the main flow. This is important because from the bank, it means you can easily pull the sensor up, look at it for cleaning, calibration, and so forth. We then have this connected via a cable through to the labellum, solar, or AC. Normally we've got this around 10 or 15 meters away. And again, this is site specific. So this is us coming onto site, looking at the stream, looking at where it potentially floods, and those 50-year weather events to make sure that obviously after your investment in 2 years' time, your equipment is still there. Next, how do we look after maintenance and support of the equipment? So the first thing to note is part of what Adroit does is pick sensors that are going to have low maintenance, low cleaning requirements. So as Maria went through, both of those sensors have their own cleaning mechanisms on them. In terms of calibration, the scan nitrate sensor is a 5-year back to calibration sensor, and with the in situ, only the pH ORP needs to be calibrated, and this is something that's done every 2 months. So what we normally recommend is someone comes onto site, brings the sensors out, gives them an eyeball, a clean, and that's when you do the calibration, and this is done via app. It's very simple to do. So either our service team can come on and look after this completely for you, or we can train your team so that they can do it themselves. And for any break fixes or problems, so forth, that's when our team can come out and fix these for you. Back to you.
Awesome. Cheers, Guy. So now we have the equipment installed. We've gone through the hardware, the connectivity. This is the fun part. So how can you get the data and how do you look at it on your platform? So just like our choice to source the best-in-class sensors and equipment, we've also sourced best-in-class IoT platform. So it's coming with all your functionalities, your visualizations, your alerts, your thresholds, your trends, and a full set of APIs. So you can access the data in 2 ways. So you can download it via an app that will work on your Android and your iOS phone, like Gavin mentioned. As you can see in the snippet on the phone, it's a point in time and you can see what's happening right now. Or you can access it via your browser. So on the left, you will see a snippet from a browser accessed version of the Furanaki platform in the Waikato. So this is your point in time. Again, you're seeing all the parameters in the widgets and you have your battery power, you have a map. If you want to see a more in-depth trend of that day, you can click into each one. But if you want a deeper insight, and this is where it gets really exciting, you go into your charts. So there's this option where you'll select charts and it will give you a list of the parameters. You'll select each one. This says last month's nitrate nitrogen graph. So as you can see, it's fluctuated quite a bit. However, it has not breached the threshold that we have set in there for nitrates given to us by the Waikato Regional Council. So we can set in your thresholds and alerts as required. All of this data can be downloaded via CSV file onto a spreadsheet, or you can pull it out by the full set of APIs, plug it into whatever app or dashboard you're currently using, plug it into Overseer, your farm plans, whatever database you need it to go to. While Gavin has made this publicly available, so the Mercury Energy dashboard has a lot of users using it with their own login. The data is the client, so it's up to you what happens with it. So yeah, that's the dashboards. Back to Guy.
Okay, cool. What are the other solutions that Adroit does that may be of interest to catchments? So one of those is weather stations. So we do multi-parameter weather stations. So that's looking at your wind, rain, solar. Now this is interesting because you can understand the actual rainfall happening on site. And when you combine this with our soil moisture sensors, and so you can do these at different depths, you can really understand how much rainfall is penetrating and how much is running off into the river and stream. One of the other solutions we do is around nitrate monitoring in groundwater. And this is where we work with Hydrometrics. And I think they're on the listening in. So hi, guys. And so this is where we've got these sensors in bores and you're monitoring the actual nitrates in the groundwater. And I guess that is us. We're going to be here for Q&A with Gavin, but it's been awesome having a chance to talk to you all. Obviously, if you want to contact your Spark.io team or your account managers to know more or get in touch with us, happy to talk. But back to you, Cheyenne.
Thanks, Guy. Thanks, Maria. Really some interesting stuff going on there. I know it was awesome for me to hear about that installation process and the amount of different solutions and sensors you guys have in place for catchment monitoring. Now, we have a number of questions coming through from our audience, but just before we get into those, we'll take a look at the poll results. So the poll question was, what is the main barrier to implementing real-time catchment monitoring? So if we take a look at those, we could see there with 46 votes in total that the biggest barriers were actually tied, and that was I need more information on how the technology works, and I will have difficulty securing the funding for the project. What do you guys think about that, Maria, Guy, Gavin?
Well, I can answer the first one. If you want more information, obviously we're here. So feel free to either get in contact with your Spark IoT manager who can, touch base with us, or contact us directly. And we're happy to go through the technology with you and have a more in-depth conversation around that. Yeah. Around the funding, I guess that's an interesting one. Gavin, do you want to jump in there for a little bit of a talk?
Yeah, look, I think that is probably one of the biggest challenges, actually. I think is securing that funding. That front end cost is significant. The capital is significant. The OPEX ongoing is the upside, but certainly I think the funding is a challenge. And I think this is where really some of the, and this is in our view, corporates like us need to try and lean into this. Hopefully, some of the larger councils will get them behind it. As I said before, great to see Fonterra doing it. Really tough call for small catchment groups to be able to fund this sort of data. So then that's another reason why we're very keen to make that data freely available, so that people don't actually have to sort of sign up for a subscription to be able to have to, pay to access it. So yeah, but no simple answer to the funding. Every situation is going to be different.
Perfect. Cool. Thanks, Gavin.
And so one thing I would just jump in there, Shine. The other thing is, because we're now partnered obviously with Spark, we do have other options in terms of payments to try and make it easier for groups and so forth. Obviously they still need to come up with the fund in some way, but it does make it easier if we can do subscription type models, interest-free type models, anything to try and, I guess, get more out there.
Yeah, absolutely.
Thanks, Guy. Thanks, Maria. Thanks, Gavin. So we'll now look at the questions that we've got coming in. So Blair's asked, hi, Adroit, can the monitoring stations be moved to different locations?
Cool. I'll jump in there. So while the solutions are designed obviously to be in one specific place and to monitor over time, yes, they can be moved. So we can, if no longer need monitoring in that place, or if you need a monitoring in a place of more importance, we can actually move the whole installation, no problems. At times, what we can do is set up installation pipes at two locations, right? So it may be that you monitor in one place for 6 months and another place at 6 months. So again, it's about being flexible with these things.
If I can jump in there too, Guy, I think, Blair, that's a great question. And Guy and I have already had some conversations around sort of, I'd love to see a couple of mobile units almost, so that, because what we're noticing certainly in small tribs and small sites, you would love to go, hey, look, let's get in there and monitor for a month and see whether it's worth continuing, see what else we can find. And given the cost of the upfront kits, I think a few mobile units is a great idea.
Perfect. Thanks, Gavin. And Gavin, another one for you coming through is, what has been your biggest challenge implementing this sort of IoT technology?
Yeah, well, I guess implementing the technology actually hasn't been too challenging, as I said before. Look, to be honest, once you find your right provider. But for us, it took quite a while to figure out where we should be going. Who was doing it well. But even before that, there's a organizational kind of challenge, which is actually figuring out that this is worth the investment, and it's the right thing to do, and comes back to everybody's why. If it's not a consent requirement, if it's not a regulatory requirement, it's hard to get the whole thing out of the blocks. Once we got it out of the blocks, the installation has run pretty smoothly, I have to say. And in terms of actually implementing the IoT solutions, we're just handing that to the Adroit team. We're doing the easy stuff.
Perfect. Cool. And so to Guy and Maria, a quick question from Chaitanya is, because you're assembling different equipment from different manufacturers, do you validate the product from a third-party testing lab?
So what we do is, first off, we've got, first thing you do is you make sure you're dealing with established vendors, right? So as Maria mentioned, we're dealing with vendors such as Iscan out of Austria, where they've been around for 21 years within this tech. And with tech, there's always multiple iterations of the tech. And so in situ, we've been doing it for 40 years. But then we bring them in-house, where we then validate them. We test all of our solutions before we put them into field. We have firmware and hardware. We're actually looking really deep into all of that and how it's actually put together. And then 100%, when we put that out into the field, we then test that with field testing. A great example would be our data boys. So we had to go through quite a stringent testing process with MPI. And so that has been MPI approved now. And so mussel farms actually open and close harvesting based on this data. So yes. So I guess an answer, yes.
Perfect. And this one out to the three of you is from Mara, is, have you considered an open data standard to share the data?
I can answer from our side, and then Gavin can answer from his. So for us, obviously, we need to be careful because we're in the middle, right? So we're dealing with, corporates, we're dealing with individual farmers, we're dealing with a range of clients. So ultimately, they're paying for the solution, and they own that data, right? And so while we can, support open data, at the end, as our company, we need to do what our clients stipulate. But over to you, Gavin.
Yeah, look, I think again, another good question, and I think this has been the cornerstone of the why for us has also been we really want to make this open source data, and we want everybody to be able to access it free. So yeah, absolutely. I think understanding, as Guy says, the why for some organisations is really different. If they're doing it as part of a consent compliance or there's some sensitivity around the data, then I understand that. But I know that there's a lot of data being collected out there that there's no reason it couldn't be given open source. So the way we're going to get this, get this movement going forward is for everybody to be looking at this data and learning from it and going, this is awesome. So yeah, we're a big fan of open sourcing it.
Perfect. And thanks, Gavin. And continuing from that one, Michelle has asked, for lay people wanting to understand what that data means, is training being provided?
Yeah, I think, good thinking, Michelle. We've obviously been doing some training on the use of the dashboard with the Adroit team, but I think that's a really good point, is to sort of, and for some of our catchment groups, we need to start talking to them about what nitrate nitrogen is, what they should expect around DO, what's good. So yeah, I think that's probably our next step, is to try to either have some links or we have some sessions like this, which where we get some of the experts to talk about what some of those numbers actually mean. Because what we have realized is, when you're building a dashboard, you've got to build it for the people who are looking at it, not for the techs or the scientists. So yeah, I think that's a good area for improvement.
Perfect. Thanks, Gavin. So to Guy and Maria, question from Grant is, have you had any network or coverage issues, and how did you overcome them?
Cool. So I'll jump in there. So first off, because we're using the CatM1 network, which, it's fantastic for devices. So quite often where you don't have cell phone coverage, you still have full CatM1 coverage. And that's why we're able to operate, in remote locations. We were able to, with King Salmon, our data boys, these are all, not easy to access. And we've had no issues at all, right? But what we've also done on the Labellium is we've built a bucket. So if there was connectivity issue, touch wood, we're still collecting that data, and then when it reconnects, we're able to resend that data up. And obviously we've got a great relationship with Spark where we're working with their team to make sure that we don't have any of these issues.
Thanks, Guy. So a question from John, and this is out to the three of you, is do you have any installations within highly populated areas? Start with Guy and Maria on that one.
So yes, we do. I mean, we work with construction sites, so we're monitoring noise, vibration, dust within that. I'm guessing this was more around the water. So in terms of a river and stream, no, we don't have one directly going through the city, so to speak. I mean, we do have one in the Otago Harbour, which is quite populated. But yeah, I guess that'll be interesting to look at as well.
Potentially, we'll be having one in Christchurch City soon.
There we go.
Yeah, I'm working on it.
And look, I think we definitely want to do it. We would love to see. We'd love to. I guess it's about educating people to what happens in cities as well. Yeah. And I'd love to get one into the outfall for an industrial complex of some
Absolutely.
sort, so that we can start to see that this is some of these are shared issues.
Mm-hmm.
And so, yep, absolutely, that's on our radar.
Perfect. Thanks. So a question from Bryce is, what is the detection limit for the nitrate sensor, and is it validated by lab tests?
So in terms of the nitrate, it is validated by lab tests. So as I was saying earlier, so all the nitrates comes from Escan, so it's a validated sensor. It comes pre-calibrated, but all of these things are then tested against labs. So that's part of making sure the solution is actually doing what it says it does.
And I know the specs talk about the detection level of detection being from, I think it's from 0 to 20 for nitro and nitrogen, right? So it's kind of, it's going to be picking up level of detection well below anything we're sort of likely to really see.
Perfect. And I got a question from Peter on if data forwarding options. So if you already have your own database system, can you forward that data?
There's a full set of. Do you want me to answer that, or do you want to go for it?
Oh, you can go.
Well, it has a full set of APIs, so it can be plugged right into any database that you're using. Do you want to elaborate on that, Guy?
And it's bi-directional. So what we can do is we can plug data into our platform via. So you can plug ours into it, or as Maria said, we can take our data and put it into any platform you've got. So it's very flexible.
Perfect. And then that comes on to another question from Mario is, what are the cybersecurity measures implemented on the actual devices?
That is a great question. So within that, we deal with firmware and hardware. And we work very closely with AWS as well. So with our platform, that's where it's hosted. So with everything we've done from the sensor through to how it gets transmitted through being collected and secured in the cloud, we've gone through a very robust security process with that. We've actually had AWS just recently go through our complete system again to make sure that everything is secure. And if anyone wants to go, get the more techie answer to that, we can sit down and go through that full process as well.
Thanks, Guy. So another question from Bryce directed towards Gavin. Is it the high frequency that's important rather than the real-time functionality?
Well, for us, it's the real-time functionality that's important. I'm not sure I'm interpreting your question, Bryce. Have another crack if I'm not. But we're just interested in the real-time outputs.
Perfect. Thank you, Gavin. So a question out to Guy and Maria. Is there a solution for detecting algae such as Dynamo that has become a plague?
So in terms of that, I'm not 100% sure what that one is, but we do, with the in situ, it does blue and green algae. So, quite often what we're doing is when we have particular use cases coming in, we then look and see if there's a sensor out there that exists that we can monitor it, and then also validate how accurate that is. So an example would be around nitrate monitoring in soil. So this is still quite difficult. So we're in the process of validating sensors at the moment. So that's where we talk with you, look at what we can monitor. And sometimes it's not about actually monitoring that particular thing. So like when you're looking at E. coli, there's E. coli sensors out there, but they're quite expensive. And so there potentially you monitor, your conductivity, your pH, your DO. So it's about understanding what else you can monitor to potentially let you know what's going on there. But yeah, happy to talk to you, around that. And once we do a little bit of research or do it in person.
Perfect, thanks. Another one out to you, Guy and Maria, is Rick is keen to know what the subscription costs are for a typical in-stream scan and in-situ unit.
Cool. So with that, we do the subscription model. It's done over a 48-month model. Depending on what it is that we end up installing, you're looking at between $500 to $1,000 a month, and that's going to include all your hardware, your installation, your connectivity, the platform costs. But yeah, let's have a chat, and I can go through it in more detail.
Perfect. So another question from Aswati is, any plans on using this sort of tech on microbial pathogen monitoring in water?
Perhaps I can have a crack at that one from our perspective, but yeah, it's definitely another one on the radar, and we're thinking about certainly, I guess blue-green algae is on the horizon, but also E. coli potentially, and we've had the conversations already that is possible, but it's a cost, and I think I think it's a sensor of 50K or so.
Yeah, we do
Guy, is that right?
We do. So in the S-Scan brand, we've got a few different other sensors on our product suite. So there's a neutralizer, a multilyzer, and a spectralizer. So spectralizer is like the full Monty. It's got everything, and it comes blank, and essentially you program everything in that you need to monitor. So E. coli and phosphorus, it can do. It's just quite expensive. And as Guy has already mentioned,
very cool names, these sensors.
Yeah, almost scary. No, but as Guy mentioned, we're always on the lookout for sensors that we can add that can do these parameters. Obviously, we'll validate them and whatnot.
And as Maria is saying, to add to that, it depends on how many sites we're looking to monitor, right? And that's where potentially having a roaming E. coli sensor alongside having these in situ scans, the neutralizers, where you're monitoring certain attributes, and when you're starting getting these spikes, it's about then coming in with either a grab sample at that point, or either with a E. coli sensor to actually get the true understanding of what's going on.
Absolutely.
Thanks. And a question from sorry, it's just dropped down, from Matthew, is what is the nitrate sensitivity range on the sensor?
Cool. Well, I think we said 0 to 20.
Yeah, 0 to 20 milligrams per liter. Yeah.
So I assume that's the same question.
Yeah.
And from Nick, one has come through is, has anyone used the data gathered to create automated solutions, e.g. water treatment?
So within what we do, so we try and limit. So we're the technologist, and we also want to try and make sure that our platform isn't a bloated platform. So basically what we're doing is we're collecting data. We have a platform where we can visualize, do alerts and thresholds, but then we're kind of handing it off to our client, right? And so that's where different clients are going to be able to do different things with it. Yeah. Some are going to plug it in via APIs and then be able to automate systems and do whatever is required. And so for others, where we're looking at like catchments, we're looking at trends over time, right? So it all depends on your use case.
Mm-hmm.
And to add to that, I guess, is if you look at king salmon, when for temperature, it's not good for fish health. So when the temperature goes too high, they actually turn blowers on underneath their fish pens and blow up cold water, which is a nice little example.
Thank you. And Michael, sorry if you missed it, but have you looked to incorporate the data streams into existing control systems or data warehouses, or is this a standalone solution?
I can jump in there again. So in terms of that, again, we're in the middle bit, right? So it depends on where our clients want the data to go. So if you look at Gavin as an example, he's been awesome and basically given that API to whoever wants it. So it's actually going into the Tarot dashboard. It's been fed to different organizations. But again, it's very client specific. I don't know if you want to add anything there, Gavin.
Sorry.
No, I think that's right. I think everybody's going to be using it for different things. And in terms of sort of feeding it into, I'm very keen on, and I think that might be where the question is going, is feeding into sort of automated sort of in-house process, in-house data that might help you make decisions. So it's kind of like, rather than just seeing the data, I think there's similar questions around sort of how getting long-term data sources and what do we do with it. I think that's the next thing. Is how do you incorporate into our decision making?
Yeah, exactly. And I mean, with the data buoy, that's happening already, right? So that's an opening and closing for the harvesting of the mussel farm. So if they actually get a poor result with the salinity, they can't actually harvest. So there's directly actioning their actions from that in terms of how they're running their business.
Cool, thanks, Guy and Gavin. A question from Matt coming through is, do you do any post-processing of data collected to maintain a consistent long-term record?
Perhaps if I can have a crack at that one, and I think it's following on from perhaps the last conversation. It's around, well, actually answer the question, no, largely because we haven't been collecting data for long enough. But I am aware that there's real-time data in the catchment going back to 2005 or thereabouts that has been collected. So there is long-term trend data out there. And again, that comes back to my point before, which is love to see as much of that data daylighted so that we can, as a community, start looking at some of the backstory and saying, what is the baseline, what has happened over time. So yeah, that data's out there, and certainly with the data we're collecting from now on, we certainly want to start looking more closely at that. We think there's a great opportunity here, maybe for a postgrad student to have a look at some of the data we're going to be starting to get over the next sort of little while, and what do we all do with it? What is it telling us?
Thanks, Gavin. Anything to add on that, Guy and Maria?
No, I thought Gavin covered it fine.
Perfect. Another question from Mario is, when do you think you might have a mobile solution? This would be great to demonstrate the potential of that solution.
Good question. One for Guy.
I was gonna say one for Gavin, buddy. I mean, in terms of validating the solution, I think the solution's already validated, right? So we have sites out there where we're monitoring in real time, where these are getting the same results as if you're doing grab sampling. So that's that solution. Whether or not we can then utilize that into effective roaming sites is something we need to work with a client with and see how that could work. So we're open to that. We're always looking at new ways of doing things. So all I need to do is get Gavin down here.
I think we just got to bite the bullet and build one. And give it a crack.
Thanks. And question from Will Murphy is, are any adroit real-time sites near fixed WRC monitoring points, and does data agree?
So we're monitoring, where we're monitoring now is exactly where I believe WRC was monitoring at the Whirinaki site. Is that correct, Gavin?
Yeah, they were, but not for the official, I'll call them official WRC monitoring sites. We're not at the moment, but that is absolutely, part of the plan, and to calibrate those against that monthly data, and because it's a good thing not just to know that our data is accurate, but also it all links into the long-term trend data that we've got for those sites. So yeah, absolutely. So the two things we're looking for is, we would like to collect in those sites, and we want to collect near gauging stations so that we can use flow data. That really is the next piece of gold when it comes to sort of richness of data, is what sort of what's what's the volume of some of the contaminants that are coming out of those smaller catchments? Because what we've noticed is really interesting when it rains. You might actually see a drop in nitrate, but that's a dilution factor. It doesn't mean to say the volume has dropped or the mass flow has dropped. So it's kind of all of that sort of richness of data that we really want to get.
Thanks, Gavin. And a question to Adroit is, do you have the tech to do this in lakes as opposed to rivers?
So,
do you want to go, Maria?
So these, the solutions we're using work in lakes, they work in rivers, they work in all places that you really want to install them. Some of them work in salt water as well. Do you want to elaborate on that, Guy?
Yeah, so basically all of our technology works in water, and we have particular solutions for freshwater, particular solutions for seawater. The only difference in doing lakes, oceans, and so forth is how you deploy it. So potentially, potentially we want to deploy on a wharf or on something fixed, and that's just about trying to limit the cost. We 100% can put a data buoy in the middle of a lake and measure from the middle of the lake. We can actually do do profiles, and we can do profiles using some of the Nexon's gear we've got going down to around 200 meters. So we've got a range of solutions depending on what that use case is, and the use case is really important, right? You need to understand why you're doing it.
I think that's a really good point when it comes to lakes too. Is that you most often you're dealing with quite stable conditions, so you may not see a lot of change over time. But if if you're picking up stratification and you're seeing the lake turn over at the right time, then those sort of things might be really useful via real time. Yeah.
Exactly, and I know depth is important in some of the lakes in the Bay of Plenty, and so we can monitor depth as well. So yeah.
Cool. And then I've got Bryce has two follow-ups. So we'll go at the first one, which is detection limits. He's interested in water quality, leaving native forests so keen on the lower end. It won't be zero.
It'd be that sort of 0.12 ppm of nitrates or something like that, Bryce. I think it's that's a good question, and we haven't got any sites where we're trying to test the tech for those lower levels. So not sure whether Guy and Maria, you've got any thoughts on that?
And I can jump in there. So obviously we've got quite a tech team sitting behind us, right? And so quite often what happens is we are sourcing a sensor for a particular use case. So if our sensor isn't to the right sensitivity, we can then look at the other sensors that actually are the right one. And that's part of what we do, is very much about making sure we're getting the right sensor for the right use case. So 100% happy to take that conversation offline, and we can go through it and look at the use case and actually look at all of the requirements you need for this.
Thanks, Guy. And Gavin, the second follow-up from Bryce is, not sure how you actually use the data in real time, except for the E. coli for health warnings, but having high frequency data seems most useful.
Yeah, Bryce, I might have to give you a call and have a chat about this one. I'm not sure. It might be my lack of knowledge, but I'm struggling to see where that's going. So unless anyone else can shed some light on that, I might give you a call offline.
Yeah, I guess we've got lots of examples of data being used in real time where it's relevant. So yeah, not sure.
Cool. Just taking a look to see if any more questions have come through. There hasn't been too many more different questions. So I'd like to thank our speakers today, Gavin, Guy, and Maria, for being so generous with their time and sharing so many insights with us. As I mentioned earlier, we are broadcasting today from our various bubbles instead of the Spark Innovation Studio, which showcases IoT, 5G, mobile edge compute, and other technologies. If you'd like to come in for a tour of the Innovation Studio when we are allowed to meet in person again, please get in touch here at innovationstudio@spark.co.nz. And just as we wrap up, I'd like to thank everyone who has joined us online and participated with the questions and on the poll. Remember to check our website, www.spark.co.nz/IoT/webinar, to see what other webinars are coming up and to register for those. There will also be a recorded copy of this webinar on the website for you to view and share with colleagues and friends. From me and the Spark Innovation Studio team, kia kaha, kia maia, kia manawanui. Thank you.
Thanks, team.
Cheers, guys.